Hey everyone, I wanted to go through the mathematics that I asked you to complete for homework, which dealt with average speed calculations, acceleration, and also net force. So I'm going to work on the board. So as I jump ahead to the first set of problems, um, I always set these up the same. So just write down or identify what is known in the problem. So in number one, an elevator travels a distance of 220 meters from the first floor to the 60th floor in 27.5 seconds. What is the average speed? Right away, we know what we're looking for. We're looking for speed. And if you look in your notes, you know that speed is equal to your change in distance divided by the amount of time it takes that change to happen. So in this situation, you went a distance of 220 meters, and you did so in 27.5 seconds. So I'm going to end up with an answer in meters per second, and you can plug in that calculation and complete it. For the second problem, we have a motorcyclist traveling with an average speed of 220 kilometers per hour. So this time they give us the speed. If they go into a friend's house a distance of 5 kilometers away, how long does it take the cyclist to make the trip? In this case, when you see the word long, it's not referring to a distance, it's referring to a period of time. So here you need to think about this a little bit differently. You can plug everything into this equation if you'd like, but instead of solving for speed, right, you'd be solving for time, which you can do with your algebra. Or you can think about it this way. If I'm going 20 kilometers in 1 hour, then that means in a half hour's time, I'm going to go 10 kilometers. For 1/2 an hour. That's what that's supposed to say. Um, or if I go half of that, 5 kilometers would take me half of a half hour, or in 15 minutes. So it would take me 15 minutes to make that trip. I think I did a poor job explaining that. If you want to go about it another way, you could plug in where your S is 20 kilometers per hour equals 5 kilometers divided by t, and then solve for t. Moving on, now we have our acceleration problems. Before we get anywhere, I'd like you to recall that acceleration is technically the rate of change of velocity, how quickly an object changes its velocity. So to find that, we use our final velocity, and we subtract from it our initial velocity, and that will tell us how much we changed. So if we speed up, that number is positive, and if we slow down, that number is negative. So all of this is divided by the amount of time it takes to make that change. So in problem number 6, a ball is dropped off a cliff and reaches a speed of 29.4 meters per second in a time of 3 seconds. What is the ball's average acceleration? So I'm looking for A, which means I must have the final, the initial, and time given to me in my problem. They tell me it reaches a speed of 29.4 meters per second. They tell me that it took 3 seconds to go that fast. But what they lack here is how fast was I going. So if you're just dropping a ball from your hand and letting it go, what was the initial velocity? Well, 0. If you're throwing it, it's another story. But if you're just dropping it, your initial velocity is 0. So you would solve this by taking 29.4 minus 0 and getting 29.4 meters per second divided by 3 seconds. I'll let you complete the math, but I also want you to recognize the units. You should end up with meters per second per second. For problem number 2, they're looking for something a little bit different. I said problem number 2, I meant problem number 7. Forgive me, it's late. A sprinter runs with an average acceleration of 4.5 meters per second squared. So they're telling you that every second, this runner increases its velocity by 4.5 meters per second. They want to know what the speed will be, the final, after 2 seconds. Again, you can approach this by plugging it into an equation like this, or you can think about it this way. If this represents my time, and I have 1 second, 0 seconds, 1 second, and 2 seconds, if I'm increasing my speed at 4.5 meters per second every second, then after 1 second I'm going 4.5, and after 2 seconds I'm going 4.5 plus another 4.5, which would be equal to 9 meters per second. Your final set of problems deals with net force. And the word net force just means total force. So if I have things that are acting in the same direction, they'll add up to a larger force. If I have forces acting in different directions, they'll end up subtracting from one another. So in question 5, it says 2 students push on a box in the same direction and another pushes in the opposite. What is the net force if each pushes with 50 newtons? So you have 2 students pushing in the same direction, each with 50, and one person returning that force of 50. So I think you can see on the left that total adds up to 100 newtons going toward the right, and my blue force is only 50 newtons going to the left. So I have 50 newtons taking away taken away from my 100 newtons, which means I essentially end up with a net force, a total force, of 50 newtons toward the right. In problem number 6, calculate sliding friction. It says you push a box with a force of 80 newtons. I always like to draw pictures for these. It makes no difference that I am not an artist. Just pretend. It says that you're pushing with a force of 80 newtons. It says that the net force on the box is 50 newtons. So that is the result. So that is you pushing one way, and it says, what is the force due to friction? Well, friction must be taking away from you if you end up with 50 newtons. In fact, friction is like the enemy of motion. It always takes away. It's not always a bad thing, but it always subtracts from your motion. So if I'm pushing with 80 and I end up with 50, how much of my effort is friction gobbling up would be the difference. It would be 30 newtons. And the final problem of this set was number 7. Calculate the acceleration, the downward force of gravity, and the upward force of air resistance on a falling ball are both 5 newtons. What is the ball's acceleration? I hope this sounds familiar to you with all our talk about skydiving and terminal velocity. So here's your parachutist. They have a downward force, their weight, the force of gravity down. And if they're cruising at a constant speed, then the upward force, the force of air resistance, must be equal. If my forces are balanced, then that means that my acceleration must be zero. So in this problem, they're talking about a ball that's falling, and that ball must have achieved terminal velocity, because the problem says that the upward force and the downward force are both 5 newtons. So that means if this is a battle of the forces, you have a downward force of 5 newtons, an upward force of 5 newtons, and just like your skydiver, balance forces equals 0 acceleration. I hope that helped you out, and I hope you didn't, get stuck too much. If you have any questions, please feel free to, obviously raise your hand and get some help. Thanks a lot.